Welcome back to my series on being an applied statistician using JAMOVI. Today, we're going to deal with a repeated measures Friedman test. This is a non-parametric test. Let's start, as we always do, with our statistical test decision tree. So let's see where we are in this T. We're still dealing with tests of difference. And this test is basically a non-parametric parallel to the repeated measures t-test. What does that mean? Well, with the test of difference, we're dealing with ordinal data or with not normally distributed data. And we're dealing with a situation where we have more than one measurement, more than one time of measurement for a variable, and want to compare if there is a difference, like a pre and post design. So in that sense, it's very much like the paired t-test, and it is the non-parametric or the not normally distributed version of the paired t-test. It works with ordinal data, or if you had planned to do a paired t-test and you found that your interval data was not normally distributed, you could always go down and do a Friedman test. Okay, when do you use the repeated measures Friedman test? Well, there are a few contexts. Let's consider the following question. Is there a difference in the preference ranking for writing poetry for students before, after, and 1 month after taking a meaningful literacy class? So in this research question, we have 3 points of time: before the class, after the class, and 1 month later when the class is finished. And the measurement we have is the preference for writing poetry. Meaningful literacy classes tend to make students do personal autobiographical poetry writing. Let's analyze this question. Do we have a grouping variable? Yes, we do. It's time. We have a before, after, and 1 month after a meaningful literacy class. How many groups do we have? We have 3, before, after, and 1 month. We have 3 measurements, in other words. Are the groups independent? No, they're not, because we have the same students, the same people, the same participants in all 3 of these time measurements, the before, after, and 1 month later. What sort of outcome variable do we have? Well, we have a poetry preference ranking. 1 is most preferred, 5 is least preferred. And that is an ordinal rank order preference. So we have an ordinal variable, which by definition is not normally distributed. We need a test that compares dependent groups, in other words, paired groups or the same groups, of students with 1 repeated ordinal outcome variable. Okay, here we have a schematic drawing of this. I've only given 2 times, but actually this could be 3 times as in our case, or 4 times or 5 times. The test can handle multiple time periods. What's important is we have the same measure at each time. So in our case, this is a poetry preference ranking, and this is also a poetry preference ranking. Well, the way this works, we collect results for time 1, we collect results for time 2. In this case, we're comparing rankings for time 1 with rankings for time 2 with the Friedman test. And if we had 3 or 4, it would be the same Friedman test, testing whether these come from the same distribution. Okay. When can you use the Friedman test? When you want to compare the rankings of an ordinal outcome variable, which was measured at least 2 or more time points, to see if they're really different. It's, if you like, a repeated measures for ordinal data. It's also a repeated measure for interval data that is not normally distributed. So if you plan a paired t-test, you find out that your data is not normally distributed, you can go down and do a Friedman test. Our hypothesis is there's only 2 hypotheses here. One is that there's no difference on the outcome measure at the different time points. That's our null hypothesis. And our alternative hypothesis is that there is a difference at the different time points. And with that, I suggest we go over to JAMOVI and look at how to perform the Friedman test in JAMOVI. As you can see, I've opened up JAMOVI and we're on the data page of JAMOVI. Let's look at what variables we have here. We have 3 variables: before poetry preference, after poetry preference, and 1 month later poetry preference. All 3 of these are ordinal data, as you can see. It's been marked here. Okay, so let's go forward and do the analysis. Let's go to analyses. Let's go to ANOVA. And down here at the bottom, you can see a repeated measures ANOVA. Friedman, this is a non-parametric test. Let me click on it. It opens up a very, very simple dialog box. Let me move all my variables into the measures. And I have my 3 variables, 3 time points. I want pairwise comparisons, and I want descriptives. So let's do the descriptives first. So let's just take a quick look at our descriptives and see what we have here. So this is the before poetry preference. We have a median of 4. For the after poetry preference, we have a median of 2. And for the 1 month later, we have a median of 2. Remember that 1 means you really prefer to write poetry, and 5 means you really don't prefer it. So we can see that there is a shift as we go down here. If we look at the mean rankings, just for a second, just for explanatory purposes, we can see that before, really, they don't really want to write poetry before the meaningful literacy class. Immediately after, they're pretty positive about writing poetry. They have a preference for it. 1 month later, this drops slightly, so it's somewhere in the middle. Okay, we can look at the Friedman test, the repeated measures ANOVA Friedman test. Here we have the chi-square, the degrees of freedom, and here we have the significance level, and we can see that this is highly significant. So there is a difference between, we can state that the data shows a difference between these 3 levels. The final thing we want to do is we do want to know where the difference is. So let's do a pairwise comparison using the Durbin-Conover method. And if we look here, this is the pairwise comparison. The pairwise comparison, a post hoc test. It compares before and after, before and 1 month later, and after 1 month later. In other words, it's a bit like a paired t-test, if you like, comparing 2 points in time going down the list. And we can see that all 3 of these are highly significant. So there is a difference at all 3 time points. So now the only thing that is left to do is to report the Friedman test and to write it up. Having done the test, now let's report the Friedman test. Let me read through the language that we use here. There was a significant difference among the measurements for the 3 time points. We then report the Friedman's test, the chi-square, the degrees of freedom, the actual chi-square Friedman test result, and the significance level. We then go on to report the pairwise comparisons if we have 3 groups, of course, or 4 groups. Pairwise Durbin-Conover comparisons found that all 3 time points before, after, and 1 month later. Please note we report the median for each of these were significantly different from each other at the 0.019 and 0.001 levels. You have here the arrows, which shows you where to find the data in the JAMOVI output. As I always say, I hope this video is helpful to you. I hope this helps you do the research that you are doing at the moment. And I'll see you again in our next video.